Hey everybody, welcome to the end of chapter 5, Reflections and Symmetry. This is the end. Actually, you've already finished all the triangle congruence theorems in previous chapter 5s. Don't forget them because they might come up later. But today we're going to be talking about reflections and Okay, so what you are going to be learning today is we are going to be learning how to identify and use reflections and lines of symmetry. Raise your hand if you've talked about symmetry before. All right, I hope you were raising your hand even though you might not be next to somebody. Okay, but let's check it out. What I want you to do on this very first one is I want you to write everything below that line. So I'll be nice today, and you can write everything below that black line, which is down here if you don't know where below is. So that kind of that area of reflection. So as I read on top, it says, recall that a reflection is a transformation. Do you guys remember transformations? We talked about a transformation earlier in the year. If you can tell me what it is, tell me right now. Let me know. Translations, yeah, you got it, translations. Okay, that moves a figure, remember that word pre-image by flipping it across a line. The reflected figure is called the image. Remember how we are able to see which one is our pre-image, which one is our image. That's going to be with your little prime symbol. Okay, if you look even down here, you can see that little prime symbol right there. We'll get to that in a second. It says a reflection is an isometry, so the image is always congruent. Look at that word. Always congruent to the pre-image. That's the very first thing you look for. Is it congruent? Okay, is it congruent? Then you can go on to your next steps. Okay, it says a reflection is a transformation. Again, that beautiful word of transformation. Across a line called the line of reflection. So that the line of reflection is the perpendicular bisector of each segment joining a point and its image. What does that mean? What in the world are we talking about? Okay, what we're talking about here is, very first thing is, check to see if it is congruent. Okay, if the shape or the point is congruent to the pre-image, you can check to see if that box is right. Okay, then what you do is you check to see if the image is reversed. Okay, when it deals with points, you don't have to really worry about if the image is reversed or not. But you can, when we talk about a shape, such as, let's talk about a shape like this, okay, you would want a shape like that as your reflection. So is that shape reversed? Check. Okay, then the question is it going to be a perpendicular bisector? Meaning, are the segments connected by corresponding points or by that line of reflection making a perpendicular line? Okay, that's the last piece of a reflection. So perpendicular, not the two shapes, but that line of reflection, is that perpendicular to those 2 points? Okay, let's check it out. Now the question that I'm going to get is, do I have to draw that? Yes, no, you don't have to. You get to draw those shapes. Sweet. Okay, get to show off a little bit of your artistic flair in your math notes, all right? So when we look at this, tell whether the red figure is the reflection of the blue figure. So if the red figure is a reflection, is the red figure going to be your image or your pre-image? It's going to be your image. Your image, yes, it's going to be the image. So the red figure is your image, your blue figure is your pre-image. Awesome. So now what I want you to do is go through those 3 checkpoints and see if it's yes or no. Be able to explain your answer, of course, but tell me if it's yes or no. Check it out. All right, so this very first one, is this going to be a reflection? As you look at this, is this congruent? Go through those steps. Is it congruent? Yes, it's congruent. Are the shapes reversed? No, and this is why it is not a reflection, because the shapes are not reversed. What you would want to see, okay, see this little section right here? We would want that to be completely flat and that to be gone, and we would want that little rectangle piece sticking out on the other side. This shape that I just drew and, just kind of erased this section, that would be a reflection. However, that's not the shape we are given. We are given this shape, which makes it not a reflection. Awesome. Okay, let's move on to the next one, letter B. Okay, which one's your image, which one's your pre-image? Pre-image is going to be this one. Your image is going to be this one. Go through those 3 steps. Do they appear to be congruent? Yes, they do. Do they appear to be reversed? Yes, they do. Do they appear to have perpendicular bisectors across that line of reflection? Well, if we drew here, that looks like a perpendicular bisector. 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 If you go across, that looks like a perpendicular bisector. We have reflection. So our answer is going to be yes. Awesome. Okay, you don't have to write this down. I'm just going to kind of explain this a little bit. When you have reflection across our axes, okay, so across the x-axis. So to go from our pre-image to our image, notice our y. Okay, our y goes from positive to negative. Our x's stay the same, but our y's go opposite. Okay, so that's across the x-axis. Across our y-axis is the exact opposite of that. Our y's stay the same, but our x's flip-flop, or they become the opposite. They become, if it's positive, it goes negative. If it's negative, it goes positive. So that's what it flips over. Okay? Last is across the y equals x. If you remember direct variation from last year, this is a direct variation line that goes with a slope. What do you think that slope is? 1. It is going to be a slope of 1, which means that what happens over this line is going to be your x and your y flip-flop. Okay? So whatever your x is, your x coordinate now becomes your y. Whatever your y coordinate is now becomes your x. Okay? So let's look at a couple of coordinate graphs. As you can see right here, I want you to be able to tell whether the grid shows a reflection in the x-axis, y-axis, or neither. So we're going to start with 1 over here and 2 over here. Be able to explain why that is. All right? Give this one a shot. All right. So if you look at number 1, okay, you go from A to A prime, right? You go from your image to your from your pre-image to your image. What am I talking about? Okay, so from A to A prime, B to B prime. Does that appear to be an x-axis, y-axis, or neither? First of all, is it a reflection? Yes, it is a reflection. Okay, if you look at these points, you will see on this first one, you will have -5, 2. Okay, and on the top, you will have -2, -6, or sorry, +6, not -6. So -2, +6. And let's look at our primes. Our primes on the bottom, we have -5, -2, and we have -2, -6. Okay, notice what changed. First of all, are they congruent? Yes, they are. Are they going to be perpendicular bisectors? Yes, right here, our line of symmetry does form a perpendicular bisector here, okay, or line of reflection, I'm sorry. Okay, but look at those points. What changed from -5, 2 to -5, -2? Well, your y value changed. So whenever you have that y value changed, it is going to be x-axis. Your x-axis changes, or it's a reflection over the x-axis. Awesome. Okay, so then when we look at number 2, okay, again, we're going to check out, first of all, is it x-axis, y-axis, or neither? But we need to see if it's a reflection first of all. So Jim is going to turn into Jim prime. All right, let's see how we look at this. So we look at Jim and we look at Jim prime. Are they congruent? Yep, they appear to be congruent. Okay, are they going to be flipped? Is the object reversed? No, that's where we have our problem. So is this a reflection of the x-axis, y-axis, or neither? It's going to be neither because it is not a reflection. Okay. Now you could also have that x-axis, y-axis, or neither, and it be a reflection over y equals x. Okay, or over the origin. But at this point, this is not a reflection, so this is also neither. Moving on. Okay, so I want you to write down line of symmetry. We talked about this a little bit. Line of symmetry, a figure has line symmetry, basically reflection symmetry, if it can be reflected across a line so that the image coincides with the pre-image. The line of symmetry, also called the axis of symmetry, divides the figure into two congruent halves. Okay, so I think you've maybe learned about line of symmetry before. Basically, that line of symmetry can cut it in half. It becomes a reflection, or you can fold that image. If you look at this heart here, you could fold that right at that line of symmetry, and each side would line up perfectly. Okay, so we're going to try a couple on the next slide. Here we go. Okay, so if we look at this, tell whether the figure has line of symmetry. If so, copy the shape and draw all lines of symmetry in this shape. Okay, so I'm going to go through this very first one. If we look at this, does this figure have line of symmetry? I'm looking at the far left at 1, this is 1, this is going to be 2, this is going to be 3. Okay, so does this figure have line of symmetry? Yes, this figure does. Okay, we have multiple lines of symmetry. Okay, so we have a line. If we drew a line straight through the middle here, that's straight-ish, but right down there, that would be one line of symmetry. So that means we would be able to fold that star in half, okay, and it would match up with the others. Would you agree? I hope so. Okay, and that's going to be true for every single point going across here. Okay, we have those lines of symmetry. So right in that aspect, we have 4 lines of symmetry. However, are we done? No, there's more. Okay, if you look at, no, there's more. Okay, if you look at this little section here, if you flipped it across that line, would that be symmetrical? Yeah, it would. Okay, so we do that exact same thing through all of these. These are my next lines of symmetry. Okay, going across here. Okay, so we have another 4 more. So how many lines of symmetry do we have? We have a total of 8 lines. Awesome. Moving on to the second one. Okay, looking at this, this is an interesting flag. Okay, so looking at this flag, you can see where do we have to draw our line. If we fold it in half, it's the exact same. It's the exact same picture. Where does that line of reflection or the line of symmetry happen? And it is going to be a horizontal line that goes straight across. Okay. Then think to yourself, can I do it any other way? Now, if I did this blue line, okay, straight up and down, notice this right side, okay, is missing a section. Okay, I wouldn't be able to fold that right in half. Those wouldn't line up perfectly. So that is not, again, it is not a line of symmetry. So how many lines of symmetry do we have? We have 1 line. Okay, again, this next one kind of looks like the red cross symbol. And we are going to make lines of symmetry here. See how many we come up with. You will notice as you start making your lines, okay, I'm going to draw this one going straight down. If you split it right in half right at that point, you will have a line of symmetry and also straight across. So there are 2 ways. There are 2 ways that you can split this. However, we are not finished. Okay, if you split this also down this middle way, okay, going right at that, kind of at that vertex, at that corner, you will notice that it also can be flipped right in half, and it will be another line of symmetry. Okay, so we have that one, then straight across here. Okay, so is that going to be it? Yes, it is. And when you, again, when you fold it, they appear to be the exact same picture. Okay, so there are 4 lines of symmetry on this one. Okay, that's all we have for you, or all I have for you today at 5.7 reflection symmetry. Once you get the assignment and finish the assignment for 5.7, we're done with chapter 5. Be prepared for a test which means I would start definitely reviewing your theorems with the congruent statements and looking at proofs. Know your proofs. All right? I'll talk to you guys later. See you.